Hi everybody, today class is about software requirements engineering. These requirements are important when people want to develop a software application. A software application is developed based on the purpose or the objectives or the goals of the company or the customer or the user who will use the software applications. These applications should bring the benefits or advantages to the user. Therefore, it is very important that the user application should work according to what is required by the users. It is also a complex task because developers need to understand the expression language that come from the users. While on the other hand, the users may come from different backgrounds, and especially in Indonesia, the users may come from different ethnic groups, different islands. Each ethnic group may have specific dialects. Java's dialects, Sundanese dialects, Batak dialects. There are so many dialects, and many of these users are still using their own dialect in their daily conversations. So another problem is that most users think that the developers know everything. Some may think that the developers know their domain area. However, we all know as a developer that is not correct. It's not correct that we know their domain area, because each domain must have specific knowledge that we as a software developer don't know about. We as a software developer always had a hard time trying to understand the terms of a domain that we are not used to hear. There's another big problem. That the user sometimes can change their mind about something that has been agreed upon earlier. The more they understand what a software application can do, the more requests of requirements may be expressed, and also they would require different things probably. As a software developer, we may refuse, or sometimes it's not easy to say no. We have a method to manage these problems. There are many more problems. That's why we need a special activity called requirements engineering to handle these stuff. So to as requirement engineering will help assist software developer to understand the problems and to propose solutions. As was mentioned earlier, requirement engineering is important to help software developer to understand the problems so that a software solution can be proposed. The activities of software requirements engineering is part of the communication phase in software process model. This is the software process model that proposed by Roger Pressman in his book. He said that every software process should consist of these 5 stages: the communication stage, planning, modeling, construction, and deployment. Communication is always will start the project initiation, and communication is important in requirements gathering. Once the user or the customer communicate with the developers, the developers usually can start the planning. The planning would consist of scheduling, costing, so they estimate the schedule, estimate the cost, and also tracking this schedule, cost, and actually the human resources as well. The third one, the modeling. The modeling would be very helpful to understand the problem from the point of view of the users. Usually the modeling help us understand when we do the analysis and the design. The next stage would be the construction, software constructions. When developers do the construction, they do the coding. Once the coding is done, then they do the testing. After that, then the transition. The software developer would do the transition between the developer side to the user side, so there will be delivery and feedback and support during this deployment. So, many of these activities would require developers, especially in requirement engineering, would require developers to ask many things to the customer or the users. The response of the users may become the foundation of building the planning. So, knowing the planning and we know the problems, knowing the size of the problem, that would help us determine the required time and the money to be spent, the resources are needed. So the more we have the requirements, the more complete of the requirements would help defining the software applications. However, some problems still exist. In most cases, users have hard time to express what they really want. And in many other cases, they do not know what to describe. Thus, the software requirements engineer or probably the software system analyst would need to do interview. They can do interview, they can do the meetings, they can do the reviews, they can have questionnaires, they can do the focus group discussion, FGD. So these things help us to do the requirements engineering. And so we need to have the definition first of requirements engineering. So the definition by Ian Sommerville, he said that the requirements engineering is the process of establishing the services that the customer requires from a system and the constraints under which it operates and is developed. The requirements themselves are the descriptions of the system services and constraints that are generated during the requirements engineering process. Therefore, it will be services, constraints that would allow the software applications to get operated, to be able to be used by the users. So these descriptions will be called the requirements. So what are the requirements? Anyway, there are two terms. Some people call these requirements, other people call these requirement statements. But both are correct. Both have the same context. So in this course, we may use these terms interchangeably. So the form of the requirements may sometimes too high level or too much detail. And sometimes most users actually they do not know how that they have a good understanding or they do not because some users may not have the some users are actually just the users, so they may not have the big idea what the software would actually do. So users usually have idea in a small part of the software applications, while the customers who actually probably somebody who the boss who pay the developers the money, they would this boss might have a bigger picture of what the software can actually do. Some users may express their requirements too detailed. The detail may be good, however, too details doesn't tell us anything. So we have as a software developer need to see everything. We need to see whether the requirements are conflicts. So we need to see them should be concise, should be precise. There are no conflicts. Each conflict would need to be cleared. We need to find somebody who can help us to resolve conflicts. Or the extreme thing, some requirements may have the form of mathematical function, like this formula. It's an Einstein model who usually depict the energy formula. So how what are the advantages of these requirements for us as developers? The first usage of requirements is for us developers to join the tenders, to follow tenders. Developers may bid the tender to get the work by proposing solutions. The customer should give a general requirements, and the developer will interpret these general requirements, and developer would give a proposal of what they think is the best solution for the original requirements. The solution should be equipped with the schedule to finish the work, the cost of the work, and also the resources to finalize the solutions. The second usage of the requirement statement is for determining the contract. The contract is a form of the document that is acceptable by the customer and the developers. The contract says what is needed by the customer, and this customer demand is transformed into what is to be developed by the developer. This contract has the power of law. The developer should execute the work what has been accepted in the documents. Thus, it is an assurance for the customer that they will do what has been promised. At the same time, this contract document is the guidelines for the developer that the customer would not ask for more than what has been agreed. As you might have seen, many customers or the users usually want more and more. However, if you have heard the Agile methodology, the Agile said it is okay for the customer to negotiate this contract. Anyway, the Agile may work for medium to low scale software development, but it is really not easy to use Agile to work on a big scale software development. The next slide would be the common abstractions. Davis says the requirements for the contract are mostly abstract. So by abstract, it means that it allows the requirements to be sufficiently flexible for the bidders to propose solutions. So then after the winner is determined, the contractor must provide a detailed definition. So we see this illustration is how a boss or our customer would give an abstract of the requirements or the global requirements or the general requirements so that the tender participant can propose a variety of solutions. This boss would give clues or hints about the requirements, and the participants would try to send the proposals. This proposal would have the proposed solution from each participants, and it usually includes the cost and the time to finalize the solution. Then the boss would or the customer would determine which one would be the winners of this tender, and then a contract would be set up, and then one of the winners, probably this guy, would set up the requirement process, start the requirement process, and he would develop a system requirement specification. He will ask questions, detailed questions to the users, and then he or she would determine the software requirement specification. Before we continue, we need to see what the system is. The system may organize into the hardware. Everybody knows the hardware. If we develop a system, we may develop the hardware, or we include the hardware as part of the solutions. Then the system can consist of the software. The software is part of the solutions, and we as a software developer, of course, this is the main thing. And also the system may consist of the data. Some projects of may require data as part of the system. Of course, we need the human, the resources to develop the system or to use the system, to use the software, because the software or the hardware cannot be executed by itself. It has to be a person or human who execute the system, the hardware or software. And then some software would or hardware would not be able to run if there's no specific process or procedures or some related facilities or materials to to run the system. So we also need to have the definition of system engineering. From this definition, system engineering consists of more than one field. It's an interdisciplinary field of engineering. It means that many of these disciplines should work collectively to reach a certain goal, and this engineering process needs to be managed because it's a complex system during its life cycle. So this is the definition of system engineering. Then we need to see the system requirements. Another form of requirements is called system requirements. It's in the system requirements. Usually, we use technical language. The technical language is there are not many users who probably knows the technical language. This is the technical stuff. When people say 16 gigabytes, 15 megabytes, many of our users may not understand these kind of terms. So only people with specific knowledge would understand this technical language. So the system requirements may be specific to some domains. The system requirements may contain statement in structured document. This structured document contains a detailed description of the functions, services, and operational limitation of a system. The system requirements define what would be implemented, and it would be possibly one of the part of the contract between the client and the contractor. And we should document the system requirements. There are other terms like users requirements. So actually the users requirements come from the users. The name says it. So everything that comes from the user, the story, or the scenario, or just a request that come from the users, they are would be called the users requirement. So the language that is used by this user may, as was mentioned earlier, the language would be the human language that most possibly, especially in Indonesia, use many dialects. These dialects may be understood by us, maybe not. If we come from different, if they use their own language, so we won't be able to understand unless we understand the language as well. So at the same time, we need to understand and interpret what they want, and then of course our interpretation may be correct, may not be correct. So we need to get validation from the user or our customer. So this is important. Let's see the examples of a library system. This building, I think if you are in Institute Technology, you know this building. This is one of the libraries in our university, in the university. So let's say we want to build a library system. Let's say we want to have a information system for library system. Or we want to computerize a library system. Before we do that, we need to have what we call the library system requirements. So we need to ask the library director. We need to ask everybody. We need to ask a librarian. We need to ask somebody who's in charge of borrowing the books or returning the books. And the library director may want a system that, of course, provide a monthly report. So everything that he or she wants should be recorded. And at the same time, there also probably the organization of business library needs. The library management would require a final report every month at the end of the month. This report contains data on the number of books borrowed, and the final number of borrowers will be calculated. The report might contain data on the books borrowed in accordance to the topic, or the number of borrowers based on the category of the borrowers, students, lecturer, or the general public. There are also probably some requirements that the report must be printed after 5 p.m. in the afternoon, 5 p.m. and at the last working days at the end of the month. So the requirements also may say that only the general administration section may print the report. So all of these are library system requirements. There will be users who require the requirements, and also probably of course the organization and business library requirements or the needs. And at the same time, we as a software developer need to see everything, every pieces in the library system. We need to see their rules and their business, the locations, the time when, especially if this is the university library, we need to see whether this is the semester days or the semester break, because each has different hours. Or if it is Monday to Thursday or Friday, that we have different hours. Or probably it's Saturday, we can have different hours as well. And of course, during semester break, what time would they open? This rule says Monday to Thursday starting at 8, finish at 16:30. Some library may open for 24 hours. So we need to see this. We need to see what kind of books that are sold. We may have a weekly collection, first year students books. We have reference book, bibliography, American corner books, Sampurna corner, this is one of the corner at our library, or Indonesian Collection Nation Building Center. So there are also many kinds of books like public collection, World Bank collection, Goethe Institute collection, Dodi Tisna Almijaya collections, and many others. And we need to see how long a type of book can be borrowed. For example, a textbook can be borrowed for 2 weeks, and maximum quota is 8 books. For the TPB collections, the first year students collection, they can borrow only for 1 week and maximum of 4 books. Public collections, so we need to see all of this, and we need to see the restriction. We need to see how the loan rules, what facilities are provided, what are the sanctions if somebody delayed to return the book. We need to see how the sanction work, how much they have to pay if somebody forgot to return the book, 1,000 rupiah per book per day. Or what if the book is stolen, the book is missing or torn off. how what should they do? The rules, like you cannot speak too loud in the library. You cannot move the the books between different shelves. You should return the book to the right shelf. You cannot write on the books. You cannot throw garbage everywhere as you like. You cannot smoke. You cannot eat. You cannot drink. Of course, many of these rules may not have to be part of the software applications. We need to see what kind of contract do we have, because the contract will say what rules to be followed. Some rules may not be in the software application. Some rules may only be just the rules, but we need to make sure that our software application does not violate any rules. And of course, we need to see the security system. What kind of security system? If this kind of security is part of the software or not, so we need to decide that. What about the accounting? Okay, so, and we also may need to see what kind of hardware required. This optical mark recognition has hardware requirements and software requirements. So we as a developer need to see whether this hardware requirement and software requirements would be used in our system. So we have to adapt our software according to this OMR requirements. And the system may also require us to see other hardware alternatives, like this kind of device, or this, or that, or that, or that, or that. So there are hardware alternatives that have to be discussed by the developers to see if the users are happy with one of that, or because it's also controlling the money as well. And of course, we need to develop the questionnaires to ask questions to the librarian, for example. What rules are related, what data must be stored, the reports. And some rules of thumb of these requirements, if we can see that not all the elements have to be computerized. Some elements may depend on the contract, because this would limit the user's requests. The size of the element to be developed also we need to see the time and the cost to develop, and of course developers should monitor the scope of the problems. Scoping is important because customers usually or tend to have different or change their mind often. So scoping process activities is important. And we have to know that these elements may still be incomplete, may still be unclear, ambiguous, conflict. So we need to have a clear understanding, because most statements from these tend to be general. We need to be able to translate this request into a language that can be understood by software designers or programmers. Okay, what the user requirements? So we can come back. We will be back to these topics. There are actually two user requirements: the functional requirements and the non-functional requirements. And these two requirements often get mixed by the users. And when I say mix, it's a mix between the actual functional requirements, between functional requirements, or between non-functional requirements, or between functional requirements to non-functional requirements. We will see more about this functional or non-functional requirements later. But most important thing is we as a system analyst must rewrite the statement of requirements in a language that can be understood by any users. And we have to remember that most users do not understand the technical language, so we need to be careful when we express things in technical terms. The statement of the need for this user can use the natural language, and we can support these requirements by diagrams or tables that, of course, hopefully can be understood by all potential users. And as was mentioned earlier, there are problems like when the users use their own mother tongue language or their human natural language because they are not clear, not concise, lack of precision. And again, I need to stress that too precise may cause document to be difficult to read, and to get it difficult means that we do not have the global idea of what the software is. So we need to have a certain level of precision, but we do not want to be too precise. We need to be clear about the requirements. We need to see which one would be functional, which one would be non-functional requirements. And we do not want to have excessive needs or excessive requirements. So this usually happens when we talk to different users. These different users may refer to the same facts. So we need to understand that. I've experienced talking to a few users. They talk about the same thing, but with the different expressions. So it's not easy sometimes, or most of the time. So this picture would tell you that we want to have a software requirement specification. This software requirement specification is actually the specification to develop the actual software, to do the design before we do the coding. This software requirement specification based on what the user says, based on the user organization rules, based on the hardware requirements, based on the system requirements, based on the business or organization requirements, based on the legal requirements, either this comes from international law, state law, provincial law, and any kind of law. And of course, this software requirements specification should be based on the contract as well. So once we finalize the specifications, this specification has to be accepted by the users, and once it gets accepted, the users should sign like a contract. Then we can start building the design, and then the coding, and then the testing, and then the next steps after that. Okay. And now we talk about the requirements property. We have functional requirements, we have non-functional requirements. These functional and non-functional requirements exhibit in software and may exist in a system. In software development, software requirement specification and must also distinguish these two characters of these requirements. And what are functional requirements? Actually, it's a statement of the requirements or the needs from the services that the system must provide, or how the system must respond to an input. Functional requirements sometimes may say what the system does not need to do. So that's functional requirements. Many users say non-functional requirements. It is a statement about the constraint of the services or the functions offered by the system. So, for example, there will be timing constraint, development constraint, standard constraints, but both types of requirements can be complementary. Even non-functional requirements sometimes get transformed into new requirements whose categories are functional requirements or vice versa. For example, if the user requires security guarantees, so it is of course it's security is non-functional requirements, but we need to see what kind of requirements that is really needed by the users. Actually, what is needed is the authentication procedures to build or to create an authentication procedures. We may develop a user login functionality. So this user login is functional requirements based on non-functional requirements. So functional requirements contain description of the system. So and it's also depend on the type of software, and how the users, and also the type of the system to be used. User functional requirements can be general in statement about what the system would do. Functional requirement of system needs to explain the services in detail. So we'll see now the example of the user requirements. The first one, users must be able to search for books. Say the functional or non-functional? Must be able, so it's functional. The system can provide data to display books for library members, functional or non-functional. Because it says provide data, so it must be functional. The system must be able to provide monthly reports. Because it says provide monthly reports, it's a functional requirement. Every book order will be given a unique order number. Be given. So it's a functional requirement. No member can borrow more than 5 books, and the loan period is no more than 7 days. We do not see any functional requirements here, so we define this as a non-functional requirements. So these are the example of users requirements. And users sometimes does not care whether this is non-functional or functional. We as a software developer needs to pay attention to these kind of requirements. So what is non-functional requirements? These non-functional requirements can sometimes be more critical than functional requirements. Let's say an example of a car auto cruise system. An auto cruise systems can help the driver to maintain the speed. So, for example, if a car equipped with the system, then the driver can set the speed to, let's say, 70 kilometers per hour. When the speed is maintained to this 70 kilometers per hour, when the car going down the hill, the car may increase the speed, but the brake system would prevent the car to accelerating. But when the car is going up the hill, then the system would accelerate the car automatically. And yeah, that's the auto cruise system. However, as a driver, sometimes they see somebody like crossing the street in front of the car. So let's say the car does not have a camera that tells the system to push the brake. So the driver of the car need to step the brake on to stop the car. When the system see the car is slowing down because the driver pushing the brake, push the brake, then the system will start to speeding up the car. So the car will not stop. That's not good, because that's why there's a need to this non-functional requirement that when the brake is stepped on, the auto cruise system must stop. This is a very critical non-functional requirements. And these non-functional requirements would be part of the system, has to be part of the system. And another thing is non-functional requirements can sometimes have an impact on the system as a whole, not just one single component. For example, the performance requirement of system will involve various components. One non-functional requirements may produce some functional requirements. So here are the types of non-functional requirements. We can have product requirements, product non-functional requirements. We can have organization requirements. We can have external requirements. Product requirements may divide it into different requirements. Usability, how easy of a system can be used, how efficient a system can be operated. So if we talk about efficiency, we may talk about the performance or space requirements. We may also talk about dependability, the security. So these are the product requirements. The non-functional requirements may consist of the environmental requirements, operational requirements, development requirements. So these three would be the organization, will be part of the organization requirements. Another type of non-functional requirements is the external requirements that may consist of regulatory requirements, ethical requirements, legislative requirements, and other requirements. So there are actually many types of non-functional requirements, and for you in this class, you need to understand every bit of this, I need you to check everything in the for each requirements from the book or from the internet. You need to understand every requirement here, because users usually talks about things. We need to be able to differentiate this kind of requirements. So this is the explanation of product requirements, organizational requirements, and external requirements. Product requirements define the behavior of the software. This is the example: the amount of memory needed, the security needs, usability needs. Organizational requirement derive the wisdom of those environments of the user and developer. This is the example of our library system. External requirements, these come from outside the system and may also come from the outside the development process. For example, software development for a bank system. We must pay attention to the rules from the Central Bank of Indonesia, or development style, which must follow the existing law so that the software does not operate in violation of the law. These are the example of non-functional requirements. If we have a library system, the browser may be implemented in a simple HTML. No need to have frames, Java, so this is non-functional. The users may say that the system must run 24 hours. No downtime. No, does not exceed 15 minutes in working hours or 3 hours outside. This is non-functional requirements. Or the development process of document submitted must be in accordance to these standards. All users must register by system. So these are the first two are product requirements. These are organization requirements. And the next one will be external requirements. These are the example of the library system. There are problems in non-functional requirements. Non-functional requirements must be quantifiable, must be able to be measured, must be able to be tested. So let's say if the user says that software must be easy to use, and errors are reduced, these statements, it's not easy to be tested. It's not easy when we deliver the software. It's not easy for us to show that the software is easy to use. It is difficult to say that the errors has been reduced as much as possible. Therefore, as a developer, we need to quantify this. We need to reword this original statement into this now. The software must be used by staff after 8 hours of training. So we would say 8 hours of training to replace the requirements that the software must be easy to use. And we may say that, and after that, for experienced users, the average number of errors that occur does not exceed 2 times for each hour. Does not exceed 2 times for each hour. It's measurable of reducing as much as possible. And we have to say experienced users, so that we as a developer can make a claim of these experienced users. They may not create errors. So this detail is defined by us as a developer, because if we use what the users the original statement from the users, then it will be difficult to prove. So it is it's a must that non-functional requirement be written in quantity, so that can be easy and objectively tested. So how to measure these non-functional requirements? Let's say the speed. We need to be able to transform this speed into the, let's say, how many transactions per second, how many user response time per event, the refresh screen time. The size can be transformed into megabytes or gigabytes. How easy to use? We can transform this into how long we need the training time, or the number of help window or screen. Reliability can be measured by mean time to value, unavailability probability, value rate, or availability. Robustness, we can measure from the restart time after value, even value percentage, or the probability of data corrupt in the value or event. Portability, we can transform this into the number of targeted system. And between requirements, there are most probably relationships. It makes conflicts occur in these non-functional requirements, especially if we have a complex system. Let's say this example is a spacecraft system. To reduce the load, the number of chips must be reduced. To reduce the power consumptions, we use low power chips. But with low power chips, it might mean that more chips must be used. So these requirements are in conflicts. We need to see which one would be most critical to follow, to fulfill. So again, in this situation, we need to have a good discussion with the users. And other thing is many of these requirements are domain based. Every domain has different set of requirements. Domain requirements may contain explanation of the system characteristics and the features that provide an overview of the domain. So the requirements based on this domain may be in the form of new functional requirements, the constraint on existing requirements, or defines a specific computing system or elements. If the requirements for this domain is not met, then the system may not work as expected. So this domain requirement is important. We need to see what kind of domain that we are involved in. If we involve in e-commerce domain, we need to be able to work together with somebody who knows the business, the accounting, logistic domain, academic domain, banking. Each domains have different characteristics. We as a developer, software developer, we know how to develop the software application, but we do not know much about the domains. So as a developer, we need to have a collaboration with people in this field, who's an expert in this field. And that's why each domain also have different quality focus. A banking application may focus on the security, while the academic application may focus on the final marking, scoring result of a student. So this would create different quality focus. Another example, if you develop a game application, of course, it would focus on how good, how entertained the game is for the users, how fun the users can play the game, how the user can get addicted to a game. The more addicted, the better the software is, the game is. And other thing is, each domain have different keywords. Of course, the banking system would have different keywords to academic domains. So this keyword is not just keyword, and it could be the term, or just words or informative words. This is the example of some keywords of the library system. So in the library, there will be borrowers, borrowing the book, return the book, types of books, book catalog number, sanctions. So these keywords are specific only for the library. While if you talk about the banking system, we have the balance, ATM, billing, clearing, transfer, interest. So you should be able to see what are the keywords for finance system, healthcare system, insurance system, transportation system, academic system, or music education system, and others. The requirements would be, there are problems with the requirement based on each domain. Of course, there will be understandability issues, because requirements are expressed in the language, in the specific language of the application domains. Some terms may not be understood easily by software developers. So this understandability of issues in the requirements. Implicitness. People who understand the problem domain really understand the problem. But sometimes they do not realize that the problem in that particular domain must be stated explicitly. This is especially for the developers who do not have a proper comprehension on the domain. There's another issue like precision requirements. Requirement statements that are not precise may cause different interpretation between the developer and the users. An example of non-precise requirements: users must be able to search for books. User may interpret this as just search the books based on the book titles that are not being borrowed. That's the user's interpretation. But we as a developer may interpret these requirements into a search for book. We do not care whether the book is being borrowed or not. So this was interpretation of the developer. Users automatically think that the books that is borrowed has to be the titles that are not being borrowed. But the original requirement doesn't say that. The original requirement doesn't say it has to be the books that are not being borrowed. So this is the precision problems. Completeness and consistency in requirements. The requirements must be complete and consistent. Complete means all required description has to be revealed. Consistent means no conflict, no contradictions. In practice, it's not easy to make a complete and consistent requirements, but we must try our best to have this kind of requirements. And next slide would be what are the process for software or system requirements engineering. And as we discussed earlier, each set would have things to recognize. First, we need to see the domain. Next, the people, the person, or the stakeholders, or the organization that is run this requirements engineering. In general, the process consists of these four: elicitation, requirements analysis, validation, and the management. And the final result is the requirements specifications. And this requirement would be carried out iteratively. From this drawing, it should be clear that this is the steps. First, we gather the requirements. Then we analyze and classify these requirements. And we create the first draft of requirement specifications. This requirement specification need to be validated to the users, or probably negotiated if we think that some requirements is not clear enough or conflicts. Then this process would be iterated. We ask more, we need to gather more requirements, we do the classification, we create the draft, then we validate it, and it's on and on. And so we need this requirements management until at some stage we have to finalize this iteration process. We cannot do this forever. Then the final result would be called final requirement specification. So these are the requirements engineering process. So we can see in another drawing that this is the iterative process from the same steps actually: requirements gathering, elicitation, the second one, analysis, creates draft of requirement specifications, and then it's circling until we finalize the document. So the definition of the requirement elicitation analysis is sometimes called requirement discovery. How to get these requirements? We can do the interview, we can develop scenarios, we can create scenarios so that scenarios happens in the real world, so we can assess the situation clearly. Of course, we sometimes need to work with the users to understand the domain of the applications. We may also involve the end user, the managers, engineers who work in the maintenance or problem domain expert, or many others that usually called stakeholders. How we do this requirements gathering techniques? We can do one-on-one interview. We can have a brainstorming discussion. We can have focus group discussion. We can observe how the users do their job every day, daily job. We can develop prototype. We can have a workshop. Even we can reverse engineer the software or the process, or we can do the survey. Please read this link. There are good. It has a good explanation of each technique. And this is the process of elicitation analysis. We do the requirement discovery, classify, prioritization. Prioritization is important. We need to see which one would be the first priority for the users. So this one would be very important for us to develop this part properly. Then we draft the requirement specification. So again, this is an interactive process. And this process we could have interaction with the stakeholders, interaction with and this system would be we classify the similar requirements. There are issues in requirement analysis. The stakeholders don't know what they really want. They don't know how to state their needs. Stakeholders state their wishes in their own terms. Different stakeholders may have different requirements. Organization type, also public politics can influence system requirements. Requirements may change during the analysis process. New stakeholders may emerge and the business environment might also change. So as a software requirement engineer, we need to see this carefully. Next one will be the characteristic of the users. When we collect the requirements, we need to see there are many kinds of users. Some users may have certain access rights. They could be the guest. The guest may have a limited access right. They could be a network admin or system admin. Some users may only understand one operational part. Sometimes they do not understand general of the system. Some users may only understand one system. For example, this example says that some users may only understand Windows. They only use Microsoft Word. Only know Facebook. They don't know, or only they know the statistical application, but they want everything. As was discussed earlier, some users, they are accustomed to communicate in their native language. And some users related to customers directly or indirectly. Some users are busy, and sometimes they are not busy but hard to find. They have different characters. They not easy to express ideas. They say they know about. They're emotional and many others. So we must be patient. We try to understand, not get emotional easily, because the most important thing is to get what the users need. So this characteristic consequently becomes our requirement statement becomes too general, not detailed, too detailed, so it does not describe the system as a whole. A conflict does occur between different parts of the system, may be inconsistent. Today they said X, next week he said he wants Y. The system may not be realistic, it's beyond the budget, time to develop is too long. So as was discussed, there are three types of users by job category: operational users, supervisor users, executive users. They have different responsibilities. Operational users have local view. Supervisor will have a bigger view, not just local, while executive have a global view. Of course, executive user may initiate the project. They do not directly have experience in operating the system, but they do have strategic concern. And the organization of users would be different from each company. Different company may have different users level of experience. From this, the X company may have this kind of structure, while Y company have different kind of structures. Each have different level of experience. So we as a software developer need to understand this level of expertise. So in summary, developer must collect various requirements, and finally we need to have software requirement specifications. That's the most important thing, because this document would be used as part of the software design, as part of a source of information for software testers and for everybody. And as a developer, we need to clarify the conflicts in the requirements, and we need to see that process of requirement engineering is an iterative process. So that's the end of our class, of this course. Thank you again. I'm sorry for my language. I'm sorry if I did not say this clearly. Thank you.